This video is for Secondary Math 2. Okay, in order to do this video, I would appreciate if you haven't already, please pause and pass out the pink worksheet titled, what you see on the screen here. Whoops, my markers disappeared. Angles of elevation and depression. If you need to pause, pass it out. As we go through these notes, please fill them in. It matches what you have on the pink piece of paper. Okay, hopefully they're all passed out by now, the worksheets, not anything else. Okay, the essential question is, what is the difference between an angle of elevation and an angle of depression? And make sure you explain in detail. So at the end of your notes, you should be writing a paragraph that explains in detail the difference between an angle of elevation and an angle of depression.
Claudette Martin, please come by the attendant's office. Claudette Martin.
Okay, so we're going to talk about the differences and fill in the blank. This first bullet point. Suppose a person on the ground sees a hang glider at 38 degree angle above a horizontal line, i.e. the line of sight parallel to the ground. This angle is the blank. Well, let's draw a quick little picture so we can picture what's going on. So we have a person on the ground, right? Okay. In the space, it's not a huge space, but you can squeeze in a picture. Then we have a hang glider. A hang glider is, kind of a human bird in the air. So we have a hang glider. Let's see. Hang glider. I don't know what they look like. There you go. There's a hang glider person. Woo! Flying in the air. Okay, now the person on the ground sees the hang glider at an 38 degree angle above the horizontal line. Now where are this person's eyeballs? Are this person's eyeballs at his toes? No. This person's eyeballs are right here. So this is his line of sight if he looks straight out. Okay, notice it runs parallel to the ground. From that line, he looks up and sees the hang glider. And that angle is a 38, maybe I should use a different color there. A 38 degree angle. Okay, this angle is called an angle of elevation because he's elevating his eyes from his natural line of sight. He's elevating up to a 38 degree angle. So elevation, we're thinking elevating eyes, which means rotating up. So this angle is the angle of elevation. Fill that in, please. At the same time, the person in the hang glider sees the person at the ground at also a 38 degree angle, but this time it's below a horizontal line. Now, where are the hang glider dude's eyeballs? Are they at his toes? No, the hang glider dude's eyeballs, if he was to look straight to the left, it would also be parallel to the ground, which is also parallel to our guy standing on the ground's original line of sight. So he's going to cast his eyes downward, and that angle, which it says right here, is 38 degrees below the horizontal line. So this here would also be 38 degrees. Since he's looking down, notice the arrow going down, he's lowering his eyes. It's not elevation. This would be angle of depression. Think about your mood when you're depressed. Is your mood rising or lowering? Like positively rising or lowering? It would be more lowering, right? So you can think of this angle as lowering your eyes, which is an angle of depression. So fill that in the next blank, please. angle of depression. Excuse me. Okay, now a certain thing here happens to that bullet point. Notice that the angle of elevation and the angle of depression are congruent. Are they congruent? I have 38 degrees and 38 degrees. Why are they congruent? Well, if you listened to me carefully just a minute ago, we said this line of eyesight for the hang glider and the line of eyesight for the dude on the ground, they were parallel. And from the dude on the ground up to the hang glider, that's what we call a transversal. A transversal intersects, crosses through two parallel lines. And so we've learned about these this year. We started learning about geometry in January. We talked about all the different relationships that happen when we have two parallel lines and a transversal that crosses through them. We have AIA. Let's write all of them down and we'll pick which one it becomes. We have alternate interior angles, alternate exterior angles, CIA, which is consecutive interior angles. CA is corresponding angles. We also have vertical angles. Now, which one are we showing here? Vertical angles, CIA, CA, alternate exterior, alternate interior. You notice they are inside the parallel lines. And this one is top left of the intersection. This one is top right or bottom right of the intersection. So they are alternate interior. So these are alternate interior angles, which is why they are congruent. Okay? All right. Scroll down. Well, I scroll. You guys just look lower. Onto paper for example 1. What is the description of angle 1 as it relates to the situation shown? What is the description of angle 1 as it relates to the situation shown? So we're actually answering in two ways here. We're saying which type of angle is it? Is it an angle of depression or is it an angle of elevation, and explaining how it is created. So angle 1 is right here. Okay, you can see there's some form of bird flying by the hot air balloon, and we have a mountain. Okay, the bird's line of sight is right here. Okay?
Laura, Emily, and Levi, please come to the main office.
And the bird is apparently looking down to, who's he looking down to? Oh, the person in the hot air balloon. So if you're looking down, this would be an angle of depression goes down. So angle 1 is an angle of depression. Okay, but we don't stop there. We keep going from the bird to the person in the hot air balloon. From the bird to the person in the hot air balloon. Yep, okay. So notice we don't just say it's the angle of depression from the bird to the hot air balloon. We're specific. Where is the bird looking? And if you follow the line, you can see the bird is going right to the eyeballs of the person. Okay? So on your homework, you have a bunch of problems like this. It asks you to give a description. When it asks you to give a description, you're doing two things. You're saying what type of angle is it? Angle 1 is an angle of depression, and how is it formed? It's formed from the bird to the person in the hot air balloon. So please be specific on your homework. Okay, let's try another one. Same picture, but different problem. What is the description of angle 4 as it relates to the situation shown? Okay, angle 4 is right here. Well, we don't have like a person or an animal, but what is this horizontal line reflecting. It's kind of reflecting like the base of the mountain. Okay, so we're always looking for those parallels, the straight eyesight out. And then this one is rotating up. Rotating up to, if you follow the line of sight, up to, oh, the dude in the hot air balloon again. Okay, so if we're rotating up, angle 4 is an angle of, now remember we're rotating up, so it's not going to be depression. Depression pulls you down. We want to go up, so elevation, angle of elevation. From, where does it start? The mountain base, or the base of the mountain, you could say, to, now be specific, it doesn't just go to the hot air balloon, it goes to the person in the hot air balloon. To the person in the hot air balloon. Oops, not writing, okay. Stop writing. Let's try that again. B, there we go. Balloon. Okay, so that's how you give a description of the situation or the angle shown. You have a handful of those in your homework, so please do it just like that. I'll give you a second to catch up, and then we'll flip it over to the back. Okay, next side. Flip it over to the back, please. Excuse me. We have a wind farm here. Suppose you stand 53 feet from the wind farm turbine, kind of like the windmill. And in case yours didn't copy very well, 53 feet is right here. 53 feet. And notice where the angle is coming out of. Is it coming out of his toes or his eyeballs? It's coming out of his eyeballs. So make sure you're not putting the horizontal line flat on the ground, because that's not where your eyes are. I don't think I know anyone who has eyeballs on their toes. Okay? Up by your head. Suppose you stand 53 feet from a farm turbine. Your angle of elevation, so we see the word elevation, we should think lifting with elevation. So here we're lifting for the elevation. The angle of elevation to the hub of the turbine is 56.5 degrees, which we have marked right there. Your eye level is 5.5 feet above the ground. Your eye level is, so this guy's eye level is 5.5 feet above the ground. So your eyes aren't at the top of your head, so maybe he's like 5'7". So that's kind of a nice height for a tall girl, 5'7". He's still growing, maybe. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? Okay, this problem has what's called extraneous information. Notice the triangle. This triangle. We have a hypotenuse. We can form a right triangle because a turbine or the windmill stands up straight, so it is perpendicular to his original line of sight. Do we care at all how tall this dude is? No, that's actually extraneous information. All we care about are the sides of the triangles. Now, here is our reference angle, 56.5 degrees. Okay, so let's go through and label our things to figure out, should we do so, ka, or toa? So, ka, toa, because I have a right triangle. Whenever you have a right triangle, often we use Pythagorean theorem if we're looking for a side, or we can use SOHCAHTOA. SOHCAHTOA is used when we're looking for a side if we know an angle and one other side. Or if we are looking for an angle, we have to know two sides. In this case, we know one angle and we know one side. So we can use SOHCAHTOA. So off of our reference angle, let's label. This side right here is 90 degrees, or is opposite of the 90-degree angle. So this is called the hypotenuse. Ooh, that yellow is kind of hard to see, huh? Let's try a different color. Hypotenuse. Okay, this side right here. Again, our reference angle is down here by the man. We're clear across the triangle, so this is called the opposite. And the last side helps create the angle and is not the hypotenuse, it's the neighbor, so it's the adjacent. So given the information we have the adjacent, and we're looking for the opposite. So think about SOHCAHTOA. Should we use sine, cosine, or tangent to solve? Well, we know opposite, and we know adjacent, O and A. So look at SOHCAHTOA. Looks like TOA has the O and the A. So we use tangent. Let's fill it in. Tangent of the angle. The angle again is right here. 56.5 degrees equals the ratio of opposite divided by adjacent. That's what TOA tells us. Opposite was X. Adjacent was 53. So X over 53. Okay, so now we have to solve for X, because that will tell us approximately how tall the turbine is from the ground to its hub. Oh, I just discovered this is actually not extraneous information. Read the question. Ground to hub. So we'll eventually have to use the 5.5. That will be used at the end. But right now we're looking for, this will tell us how tall or how high the turbine is above the guy's eyes, his original line of sight. Okay, so to solve for X, I notice it's dividing by 53. So I'm going to times by 53, because that's the inverse. Notice I'm timesing on the top so that it will cancel out. Okay, that gives me 53 tangent 56.5 equals X. So everything right here on the left-hand side is something we can calculate with our calculator. So if you need to pause and let everyone pick up calculators, please do so. Really, they should be picking up their calculators as they come into class. If you need to pause, time is now to pause to make sure everyone has a graphing calculator. Everyone needs one. Okay, at this point, I hope everyone has a graphing calculator. Before we go through and type this in, let's make sure we're in the right mode. Check out what this 56.5 represents. Is this radians or degrees? You should notice right here, it's actually even labeled as degrees. So we need to check the mode of our calculator. So I actually have mine right here. I go into mode. The third line down, make sure degree is actually highlighted. Okay, if it's highlighted, then you're good to go. Second quit, and we're going to type it in, and I've forgotten what it was. 53 tangent 56.5. So type that in. 53 tangent 56.5. Okay, I'll let everyone type it in, and excuse me, and hit enter. All right, so we get approximately 80.07. Didn't tell us how to round, so I'm going to go to the hundredth. 80.07, because the hundredth is a good place to round. 80. I forgot it already. 07. Now, I did just catch that it said from the ground. But 80.07, I have a lot of stuff on here, so I'm going to erase this really quick. 80.07 is only from here to here. How far away was that line of sight to the ground? Again, it was 5.5 feet. So 80.87, since everything else was in feet, this is 80.87 feet right here. 80.87 feet, we just add the two together. Add those together, 80.87 plus 5.5, and we get 85.57 feet, approximately, from the ground all the way up to the windmill up there, the turbine. Okay, one more problem for the notes. Pictures help a ton. So, I hope you're looking at the pictures, and I hope on your homework you draw the pictures and you label the pictures. To approach runway 17 off the, how do you say that? Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. Okay, so we have our plane right here. And the nose of the plane, if you look straight out, has, a natural elevation that is parallel to the ground. And since we're descending, which way does that rotate? Does that rotate up or does it rotate down? Descending would be an angle of depression rotating down at 3 degrees. And it tells you the height at which it starts doing this. Okay, it starts doing this at 2,714 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airplane at the start of this approach? Okay, so right here, the airplane, again, is 2,714 feet. Well, I have a question. Since this is parallel to the ground, if we're going to use SOHCAHTOA, we need a right triangle. So since this is parallel, could I draw a right triangle and say that the airport is also 2,714 feet above that natural line of sight? I think I can, and then I'm going to do a right angle. Or you could have used the bottom triangle, because we know, and we talked about this at the beginning of the notes, that this angle right here and this angle right here, and the angle of depression and the angle of elevation are both 3 degrees because they are alternate interior angles. So you can use either way. So essentially we have a triangle. That's a right triangle because altitudes and the ground, the base, are perpendicular. And we have this is 3 degrees, and we have this height is 2,714 feet. So how far from the runway is the airplane when they start this approach? Here's the plane, here's the airport. Okay, well, how do we measure distance from the airport? Do we measure it horizontally, or do we go straight at it and measure it diagonally? I think we would choose diagonally, because the plane's going to fly diagonally. It's not going to go horizontally and then just nosedive straight down. It's going to take a gradual angle down. Okay, so that is our X. Again, the first thing we should do is label the triangle. We've been practicing labeling the triangle for like a week now. I hope you're becoming more comfortable. 3 degrees is our reference angle. So please take a moment, and I'll let you try it first, and then you can check with what I do. Please take a moment and label your hypotenuse, opposite, and adjacent, please. Take a moment and label hypotenuse, opposite, and adjacent, corresponding to where the reference angle is on my triangle. Okay, now I want you to turn to your neighbor, and substitute, please make sure they actually do this. Turn to your neighbor and have them compare with the neighbor. See if they label the exact same way their neighbor did. If you need to pause, they can do that. Please pause. They need to be checking with their neighbor to see if they labeled the same way their neighbor did. And if they did not, then they need to have a discussion of who was right and who was wrong and how to fix it. Okay, now let's see how you did. Since this is 3 degrees, the only side of the triangle not creating that 3-degree angle is right here. It's also the furthest away side. So this would be the opposite, OPP. I hope you got opposite there. Next, opposite of the 90-degree angle is always the longest side, which is the hypotenuse. So the only side we don't have any labeling on whatsoever would be the last side that creates the angle with the hypotenuse, and that is the adjacent, because adjacent is the neighbor. So the two we have to use are the opposite and hypotenuse, because one is the x and one is the length that we actually have information about. So we think of SOHCAHTOA. SOHCAHTOA. Which one has an O and an H? I think it would be so. So we will use sine. Sine of our given angle, 3 degrees, equals opposite over hypotenuse. Opposite is 2,714 divided by hypotenuse, which is x. Now let's go ahead and use inverse operations to get x by itself. Right now we have a slight issue because x is in the denominator. Notice it says divide by x, so what's the inverse of dividing? Multiplication. Let's multiply. Notice I multiply on the top. The reason I want to multiply on the top is so that I can cancel. Anything divided by itself cancels out to 1. X times sine 63 degrees now equals 2,714. All right, we have x on the top. Now we need to get x by itself. Look at the inverse operation, or look at the current operation, and think about what is the inverse. Here I see multiplication. So the inverse of timesing is dividing. 63 degrees, divide by sine 63. Now let's go plug and chug. Again, your calculator needs to be in degree. Type that in. This is what we're typing in right here. 2,714 divided by sine 63. I'd appreciate if everyone was participating and everyone has their calculators out and everyone is typing with me. All right. You should already be in degree because we got it into degree earlier. If you have not changed it to degree mode, make sure you're in degree mode. 2,714. Please type that in. Divided by sine 63. Enter. Let's see if it tells us how to round. Just says, oh, I think it does. To the nearest, yep, right here. The nearest 1/10 of a mile. How far? From the runway of the airplane at the start of the approach. And the approach is that diagonal line. So to the nearest 1/10, we have 3,045.0.99. How does that round to the nearest 1/10? 30, sorry, I just keep saying 30, I don't mean that. 3,046 point, if we're rounding to the 10th, I need the number on the 10th place. So it'll be 3,046.0. I know it's weird to put a 0, but it is a placeholder because we were asked to do to the 10th. 3,046.0. Take a look at where x was. Does x need a degree, or does it need feet, or miles, or elephants? What is it? It is feet. Your homework is here on the bottom. Ooh, oh, where did it go? That's not what I wanted. Okay. Here on the bottom is your homework. Page 778, numbers 1 through 17, and 22 through 25. You now have the remainder of class to open up your books and to work at your seat. You can work with people who are assigned to sit next to you, but please do not change seats Just stay in your assigned seats. And you may work with neighbors if you are working. There is a difference between working and socializing. So substitute, if they are socializing, you can tell them that their time to work with partners is over and they must now work independently, quietly for the rest of class. Okay, so if you want a chance to work with your neighbor, please do it efficiently. Page 778, 1 through 17, 22 through 25. And that is due next class. Thank you. If you need help, this video will also be uploaded to my website.